One way that we characterize a material is by offering a report that is based on atomic concentrations. The quantification parameters dialog window has a property page which is regions, and the function of this property page is, given a spectrum such as the one you see here, each peak of interest can have a region created which has the following properties. So I'm first of all just adjusting the limit to this region, but the idea is for each peak we assign a name. So this one is an oxygen 1s. That's one field. This is important. This field will be reported within any quantification report. The relative sensitivity, that is giving us the scale factor that we need to apply to this peak in order to compare it to other peaks within the spectrum. You've then got a start and an end field. These correspond to these vertical lines that I defined by using the mouse. A background type, this is currently set up as Shirley. There's an average width. The average width is related to these endpoints here, and it determines how the background approaches the data itself, and this is used in conjunction with two other fields, which is a start offset and an end offset. So in the event that we need to lower the background relative to the spectrum intensities, these two fields here will allow that. You've also got a cross-section field, which is typically related to the cross-section used in a 2-GAR approximation, but is used by other background types in CASA. And then you have a tag field, which is a string, and the string can be another way of referencing this particular region. That's to say, in addition to using the name field here. So two strings are associated with a given region, and then from a region defined with a background, it will then report back the area as calculated, the intensities above the background. You've then got a value that is a standard deviation, and you can calculate this by a Monte Carlo procedure, and will update once you do that calculation. So this peak here has an area standard deviation that is reported in the field standard dev area. It also reports back a full width half maximum that has again been calculated from the data. So the width of this peak is characterized by this number here. The position is reported, which is the maximum intensity, and you can see there's a vertical line indicating where the maximum intensity has been computed. It then reports back also a cumulative atomic concentration. It's currently saying 100% because there's only one peak defined, but as more peaks are defined on this spectrum, the atomic concentration values will build up. And other less relevant to XPS are the maximum height, minimum height, and the peak to peak. These are more related to Auger type measurements where you're looking at differentiated spectra. But for the case of XPS, a region defines the information that we need to quantify these data. So given that I know this is an oxygen 1s, I will update the relative sensitivity factor by placing a hash and then the name which is in the element library and return, and that updates the relative sensitivity factor for this oxygen. And I can go through and I can create myself another region here, and this one is a nitrogen 1s, and again I will just put a hash in there to update the relative sensitivity factor. And you can see now that the atomic concentration, because I've got two regions defined, this is starting to update. And I could go through and I could add regions in this manual mode for all of the peaks that I recognize in this particular spectrum.